And yesterday I left you with an assignment or homework, and there you were supposed to let's just look at the question. Okay, so this is the problem that we had yesterday. So in here we have our Cartesian plane XY, we have a circle, and we have the points along the circle. And the question was for us to determine the coordinate of P, knowing the equation 3x minus 2y minus 44, and you were given the coordinate of the point Q, which are 4, -2, and R, which are 12, -18. So I told you, in order for you to be able to get that coordinate of P, you must use a principle that the radius here are, the radius PQ is equal to the radius PR. And you know that PQ on its own is also a distance that you can calculate. So basically what you have to do here, we do PQ squared equal to R equal to PR squared. So here also, before you do PQ squared equal to PR squared, remember you were given that equation, which is 3x minus 2y minus 44 equal to 0. So this was the equation of the line whereby P is a point also. So what you are supposed to do, remember that point P has coordinate x and y. So you can just, first of all, make y the subject of formula, and by so doing, you're going to get 3/2x minus 22. Therefore, you're going to see that your coordinate now will be x and 3/2x negative 22. So these are the points of P, knowing also the points of the coordinate of Q and R that you'll be using in order for you to get the desired coordinate of P. So basically here now we're going to use the distance formula PQ squared equal to PR squared. So by so doing, you're going to see that you'll have x minus 4 all squared plus into bracket 3/2x minus 22 minus into bracket minus 2 all squared, which is equal to now x minus 12 all squared plus into bracket 3/2x negative 22 minus into bracket negative 15 all squared. So from here, what you can just do, you can now expand, and after expanding, you're going also to reduce your calculation. So you're going to get in the next step x minus x squared minus 8x plus 16 plus now into bracket 3x minus 40 divided by 2 all squared, which is equal to x squared minus 24x plus 144 plus into bracket 3x minus 8/2 all squared. So that is now where you're going to write x squared minus 8x plus 16 plus into bracket 9x minus 240x plus 1,600 divided by 4 equal to x squared minus 24x plus 144 plus 9x squared minus 48x plus 64 divided by 4. After that, you can group the like term together, and that's what we're going to look at the next step. So by grouping the like terms together and reducing, you're going to see that you'll have 4x squared minus 32x plus 64 plus 9x squared minus 240x plus 1,600. So here, what I've just made here, if we go to the previous slides, you're going to see that what we just made here is just to multiply the whole of the left-hand side by 4, and also to multiply the whole of the right-hand side by 4, and then we can easily simplify or cancel the 4. So that's why you see that the next step here will give you 4x squared minus 32x plus 64 plus 9x squared minus 240x plus 1,600, which is also equal to 4x squared minus 96x plus 576 plus 9x squared minus 48x plus 64. So after this step, this is where now you can group the like term together and also reducing them. So by so doing, you're going to see that the next step here, because this 4x squared and this 4x squared, they can cancel out. Now you're going to have minus 32x and minus 240x, which is about negative 272x on your left hand side. And here you're going to also have, when you take the 64 on the left hand side, you're going to get okay, it's plus 1,600. Okay, when we do when we group the like term together, we're going to see that on our right hand side, we're going to have 1,064, as you can see here, the 64 plus the 1,600, which is equal to the negative 144x plus 644. And after reducing, you're going to have 128x, which is equal to 1,024. Therefore, x is equal to 8. Once you get the 8, you can come and substitute the 8 in here. And by so doing, you're going to get y equal to 3.5 of 8 minus 22, which is equal to negative 10. And you're going to see that now the coordinate of the point P that you are looking for are in here, x and negative 10. I don't know, have you guys also gotten the same answer when you were doing it at home? Remember, this was also a homework. Did you guys get the same answer, or are you guys understanding the steps? Okay, before we go to the next question, should anyone has a question, feel free to also write so that we can attend before moving. Okay, that's good, Carlos. And the others, did you guys try to attempt the question or not? Okay, so we're going to, okay, that's good, Alpha and Siabokwa. Okay, so we're going to carry on. We're going to carry on again with another. Okay, where did you go wrong, Cheslin, where did you go wrong with the step? I'm sure it might have been, for example, a sign. Maybe you made a mistake around the sign. So when you do this step, don't just go step by step. Go step by step so that you don't make a mistake on the sign, because only a small mistake like a sign can make you can just put you aside getting the wrong answer. Okay, so we're going to again carry on. So today again, we're going to do more application on the equation of the tangent line. Remember, you first have to know the basic equation of the tangent line, but you also have to be able to apply those definitions on complex questions. So that's why you see that we're doing some of these questions so that you can be able to apply them, because they will not be as easy as the first day as we did. So today we're going to carry on with another question. So here is the question now, and it's a bit long. So you guys, you can write it wherever you are, and you just write the questions, and we're going to look at each solution per question. So the question is, the straight line y equal to x plus 2 cuts the circle x squared plus y squared equal to 20 at P and Q. Calculate the coordinates of P and Q. Determine the line of PQ. Determine the coordinates of M, the midpoint of the chord PQ. If O is the center of the circle, show that PQ is perpendicular to OM. Okay, the next question. The next question here will be determine the equations of the tangents to the circle at P and Q. Determine the coordinates of S, the points where the two tangents intersect. Determine the equations of the two tangents to the circle both parallel to the line y plus 2x equal to 4. So I go back again. I go back again so that you can, if you did not finish writing the question, you write the straight line y equal to x plus 2 cuts the circle x squared plus y squared equal to 20 at P and Q. Calculates the coordinates of P and Q. Determines the length of PQ. Determine the length of PQ. Determine the coordinates of M, the midpoint of the chord PQ. And then if 0 is the center of the circle, show that PQ is perpendicular to OM. Okay, I see there is a question. Okay, so you're going to see now the next question is I think Gagasi asked the name of the textbook. Okay, this is you'll see it at the end of the lesson. I think it's on Siavula. It's also on Siavula. All right, so let's go to the next question. Determine the equations of the tangents to the circle at P and Q. Determine the coordinates of S, the points where the two tangents intersect. Determines the equations of the two tangents to the circle, both parallel to the line y plus 2x equal to 4. Okay, so we're going to look at the solutions now. Okay, so for the first solution, remember here you have to substitute. You have to first, remember you have x squared plus y squared equal to 20. So from there, remember this circle is when the center is at 0, 0. Okay, I see someone is having a question or a comment. Okay, that's correct, Carlos. All right, so you're going to see you have to substitute. Remember, you are given the line y equal to x plus 2, and then you are given also the equation of that circle, which is x squared plus y squared equal to 20. So what you can do here is, in this case, remember you are looking for the coordinates of the 2 points P and Q, knowing the line y equal to x plus 2. So I guess you're going to see that that line will cut the circle into 2 points. That's the one that you are looking for, P and Q. So in order for you to find it, what you do, you substitute y into this equation here. You substitute your y into x into y squared, and by so doing, you're just gonna have x squared plus bracket x plus 2 all squared, which is equal to 20. So from here, what you'll have is x squared plus x squared again, plus 4x plus 4 equal to 20. And then you'll have 2x squared plus 4x negative 16 equal to 0. And from here, this is now a quadratic equation that you have seen from grade 10. So you must be able to remember it. So what you have to do here, you just do the factorization. So you're going to have, or if you see, for example, everything here is a multiple of 2. So the first thing that you do here is to divide by 2, and you get x squared plus 2x negative 8, and then you factorize. And by factorizing, you have x minus 2 times x plus 4. Therefore, you're going to see that you'll have x equal to 2 and x equal to negative 4. So those are the coordinates of, those are the x coordinate of P and Q. So what is just left here is for you to substitute those x coordinate into this equation of y. Okay, someone, okay. Okay, Carlos is asking if that equation that I'm substituting into, is it the circle equation? Yes, Carlos, this here is the equation of the circle, x squared plus y squared equal to 20. This is the equation, x squared plus y squared equal to 20. This is the equation of the circle, which passes through the origin 0, 0. And this line, y equal to x plus 2, is the one that cuts the circle into those 2 points P and Q. So y equal to x plus 2 is the one that cuts the circle into the 2 points P and Q. And that's why you remember y is equal to x plus 2. Therefore, you can just substitute y into the equation of the circle here. And by so doing, you'll end up with a quadratic equation. And after you ended up with the quadratic equation, you're going to solve for x and y, and it's going to give you those 2 x coordinates for P and Q. Okay, alpha is the radius here. Remember alpha, the radius according to the standard format, you know that is x negative a all squared plus y negative b all squared equal to r squared, So you're going to see that in here, the 20 is not the radius. R squared here is 20. Therefore, the radius is square root of 20. So don't make that mistake. The radius here is square root of 20. Yes, Cheslin, the radius there is square root of 20. All right. Now, we're going to look at the y. So you're going to start, once you know the x coordinate, you have x equal to 2 or x equal to negative 4. Therefore, you see that if x is 2, you'll have y equal to 2 plus 2, which is 4. Now, if x is negative 4, you'll have y equal to negative 4 plus 2. Therefore, is equal to negative 2. So it gives you the points P, which is negative 4, negative 2. So this is how you can solve. You see that if you have a line that cuts the circle into 2 points, and you are asked to find those 2 points, knowing the equation of that line, you make, for example, one variable as a subject of formula, for example, y equal to y in terms of the x, and then you go and substitute it into the given equation. That given equation can pass through any point or through origin, like in this case. You just have to substitute in that equation, and then you're gonna get a quadratic equation or even a cubic equation that you can easily solve. Okay. Okay, Cheslin is asking, how do you know which coordinate is which? Okay, now, in order for me to know, I could have said, I see where I see your concern, Cheslin. Okay, x is 2, q is negative 4. It doesn't matter. You could have said, for example, that q is, in this case, negative 4, negative 2, and p is 2, 4 in this case. because you are not given any graph. You are not given the graph. So in this case, you can assign P and Q any of these coordinates. For example, P can be 2, 4, and Q can be -4, -2. In this case, it doesn't matter. All right. Yes, either coordinates here could go for P or Q in this case, because here it was just a equation without a graph. So you can assign the coordinates, you can assign the coordinate P -4, -2, or the other one. So in this case, it doesn't matter. All right. So we're going to go to the next solution. And while also, I hope you guys are also trying to do them. Don't just wait for the answer. And while you're also doing them, try to also put some of your comment on the social media as well, the answer that you get. Okay, so now the next one. Okay, the next one, remember, we are trying to, in this case, okay, let's just go to the question so that you see again the question here. So in this case, here, remember, you are asked to determine the length of PQ. You already know the coordinate of P, and you already know the coordinate of Q. Therefore, you can easily calculate the coordinates of the length of PQ. Is there anyone who has a problem with calculating that length? All right. So we're going to go to that length now.
Mr. Evans, please find my office. Thank you.
All right. Okay. Okay, that's good. All right. So all right, so here was for you to just calculate the length PQ. You already know the coordinates of the 2 points. Always just also if you write the formula, square root of x2 minus x1 squared plus into bracket y1 minus y, okay, it's supposed to be y2, it's just a typing mistake. So it's y2 minus y1 all squared. So it's square root of x2 minus x1 all squared plus bracket y2 minus y1 all squared. Therefore, it's going to be the square root of -4, -2 all squared plus -2, -4 all squared. And it's going to be the square root of 72, or the square root of 72. Here, you're going to get 6 square root of 2. So that will be the length. Now, the next question here was for you to find the coordinate of the midpoint M. Okay. Sorry, let me just look at the question that one of you asked. Okay, can you write the answer as 8,49? All right, I will say for you to be in the safe position, just leave it as it is. Don't write, because okay, you can say 8,49. Why not 8,5? So I will say that leave your answer with the square. With the square is for you to be in the safe position. So leave the answer with the square. So because also one could have said it's supposed to be 8,5. Remember here they did not ask, for example, to round your answer to a specific significant figure. So better leave it with the square root for you to be in the safe position. if they say leave the answer maybe to 2 decimal place, that's what you can do. You can now write as you have written 8,49, but if they did not, just leave it with the square root for you to be safe. All right, now to determine the midpoint, remember the formula, you just use, you also have the coordinates of that PQ. So the midpoint formula, you use x1 plus x2 divided by 2, which is equal to y1 plus y2 divided by 2. Therefore, you'll have -4 plus 2 divided by 2. And the y1 will be -2 plus 4 divided by 2, and you're going to get -1 and 1. So those are the coordinates of the midpoint. Now the next one. Okay, now the next one was for us to show that PQ is perpendicular to OM. Remember, O here is the center, and M, this is the midpoint of the midpoint of PQ. So what you just have to do here, remember you have to find the gradient M of PQ. In this case, is 4 minus 2 divided by 2 minus 4. In this case, you'll have 6 over 6, which is equal to 1. And then you go for the gradient of ON, which is in this case 1 minus 0 divided by -1 minus 0. And in this case, you're going to get again -1. Or remember, we have said that two lines are perpendicular if their product is -1, and that's what you get here. Therefore, by showing all this step, you have shown that PQ is perpendicular to OM. Okay. Now the next question was for us to be able to, okay, let me. Okay, Cheslin is asking, how do I know that the center is on the origin? I know it because of the given equation of the circle. I know it because of the given equation of the circle. Remember, the circle that was given there is x squared plus y squared equal to 20, and we see that the radius there was square root of 20. That's what we say, that the radius there is square root of 20. Therefore, we're going to see that the circle here will pass through the origin 0, 0. The circle there will pass through the center of origin, which is 0, 0. I don't know if I've answered you. Is there anyone else who has a question here? All right. Okay, so here, I think I've just gone a bit one slide forward. Let's go to the previous slide. So here, what you have to do for this question 5 here, the tangent at P. I think here we are finding now the equation of the tangent line at P and Q. So now we are finding the tangent at P and at Q. So you're going to start now the tangent at P. First, what you have to do, you determine the gradient of the radius between the point O and P. Remember that the circle is passing through the origin 0, 0, and then you have your point P, and then you have the other point Q. Therefore, you're going to start from that center to the point P, which is now giving you the radius OP. You can also calculate the gradient. So that's why you see that I wrote MOP, which is going to be, you know, y2 minus y1 divided by x2 minus x1, which is equal to -2 minus 0, all divided by -4, -0, and you'll get 1 over 2. Now, when you let the gradient of the tangent at P be MP, you're going to see that the tangent of a circle is perpendicular to the radius. Therefore, you're going to write MOP times MP must be equal to -1. You write MOP times MP equal to 1. Therefore, you'll have half times MP is equal to -1, and therefore your MP here is equal to -2. And once you know the gradient, remember you can write now the equation of that tangent line as y minus y1 equal to m bracket x minus x. So I think in the first lesson, someone asked if you can use it. I say, yes, you can use it. Or you can also use a standard equation, which is y equal to mx plus c. You can also use it. It's the same thing. So in here, you know y1, your y1 here is -2, and then your x2 here is -4. That's why you see that you have y plus 2 equal to -2 bracket x plus 4. And you'll have y equal to -2x minus 8 minus 2. Therefore, this is the equation at point P, the equation of the tangent line at P, which is y equal to -2x minus 10. Is there anyone who has a question in here before we go to the equation line at point Q? If you have a question, just feel free to write and I'll look at it. Okay, so the tangent at Q here, you first also do the same thing. You determine the gradient of the radius OQ. Now, MOQ here, you also write the formula y2 minus y1 divided by x2 minus x1, which is equal to 4 minus 0 divided by 2 minus 0, and you write equal to 2. And you also do the same formula. MOQ times NQ should be equal to -1. MOQ times NQ should be equal to -1. Therefore, you're going to start your MQ is equal to -half, and that's the gradient. Now, once you know the gradient, you substitute that gradient into the standard equation line that you know, y minus y1 equal to m bracket x minus x2, and you substitute the point Q here, which is now 4. Therefore, you have y minus 4 equal to -half times into bracket x minus 2. You're going to see that y will be -half of x. So you must write -half of x plus 1 plus 4. Therefore, the equation of the tangent line at Q is equal to -half of x plus 5. Is there any question? Okay, so we're going to go to the next. The next one was for us to find the coordinate of S. The next one was for us to find the coordinate of x. So what you do here, remember, you already have the two tangent line. You already have the two tangent line, and this is question 6. So you already have the two tangent lines. So what you just have to do here, you just equate the y of the two tangent line. So you're going to have -2x minus 10 equal to -half plus 5. And once you have written that step, you're going to now go to the next one. Remember here you have -half of x plus 10. So you make sure that you find the common denominator factor. In this case, you multiply 5 by 2. That's why you get x plus 10. And you multiply also the minus 2x minus 10 by 2. That's why you get the -4x minus 20. And then grouping the like term together, you're going to get -4x plus x equal to plus 10 plus 20, and -3x equal to 30. Therefore, x equal to -10. So once you have this x coordinate or x value, you can substitute to any of these. It doesn't matter, to any of the tangent line that you got. So by so doing, you're going to see that if you substitute it here, you'll have -2 times -10 minus 10. That's why the answer is 10. And if you do also, you're going to get the same answer. You're going to get also 10. That's why you see that the s coordinate of s are -10 and 10. The s coordinate of s are -10 and 10. All right. Now, okay, the next question here is for us to find the tangent at P. Okay, Ndu is asking, where did I get -4 in step 2? Where did you get -4 in step 2? Okay, Ndu, I repeat myself. Here is the first step is -2x minus 10 equal to -half of x plus 5, right? Now, remember it's -half of x plus 5, -1/2 plus 5. If you find the common factor here, so what I mean here, you write also 5 with the denominator 2, you're going to see that it's becoming 10/2. So if you rewrite 10/2, it's going to give you 5. Now, you're going to end up now, this -1/2x plus 5 will become -x plus 10 divided by 2. So that's the one that you get in the right-hand side. So that denominator 2 in the right-hand side, you multiply it by -2x minus 10 to cancel out the fraction. If you look at the second step, -4x, if you look at this second step, -4x minus 20, if you divide this one by 2, if you divide the second step by 2, you're going to get the first step. So you're going to start, in other words, -2x minus 10 equal to -half of x plus 5. I have just rewritten it as -4x minus 20 equal to -x plus 10. So what I did here, remember I could have -x plus -x plus 10 divided by 2 equal to -2x minus 10. But now what I do to cancel that 2, I multiply that 2 with -2x minus 10. That's how I get the -4x minus 20. Okay, I hope, okay, I get, okay, I'm happy to see that is okay now. So, I will leave you with question 7. I will leave you again with question 7 for you to go and do it as homework. And also, it will also be good, for example, when we come to the let's say to the next lesson, if you have done some question that you, or even the homework that you did not understand before, if you had some challenges, we can attempt them. So don't also feel free to write your question on the chat room so that I can look at it and also answer it. So I'll leave question 7 to you as homework. So the whole of this week, we're going to emphasize a bit also again on equation of the tangent line, so that when we start next week, we're going to do another topic as function. So we're going to stop for today here, and we'll see again tomorrow. Practice and practice and practice. Okay, see you tomorrow.